So question 16. This is the first of the 6 mark questions on this paper. The diagram here, which is not drawn accurately, shows a parallelogram inside a triangle. The marked lengths are equal. So this length, this length, this length, and this length are all exactly the same. What is the value of X? Now, for me, the key is that you've got a parallelogram in the center, because that gives us some key information. And the fact that you've got isosceles triangles here and here, because the lengths are the same. They're actually different. They've got different angles in this and this and this. Am I right? 2 lengths, yes. So you can have different angles because you've got a triangle with two lengths the same, or they can be different. They can be different angles at the. They can be different angles. So what we've got here is we've got a parallelogram, and the properties of parallelograms say that these opposite angles are equal and these opposite angles are equal. So this is when these are parallel. Okay, so we're going to deal with that. That's going to be useful as part of what we're doing here. As I said, we also have isosceles triangles. So this angle here is going to be the same as this angle here. And I'm going to call those 2 angles Z. And this angle here and this angle here, I'm going to call Y, because this angle here is the one that we're going to call X. So we're going to start by looking at the relationships that we've got. We are told, no, we're not. We are told about the length of those sides here, but we know what, how to describe this angle just here. This angle here will be 180 subtract 2 lots of Y. And this angle here, and therefore this angle here, will be just 2Y. Because it'll be 180 subtract 180. And then we're at, let me just write that down, 180 subtract 180 subtract 2Y is the same as saying 180 subtract 180 add 2Y, which just leaves us with 2Y. So this angle here is 2Y. This angle here is going to be 2Y. And conversely, the same with this corner here. This one's going to be 2Z, and this one's going to be 2Z as well. That means that we can form an equation. We can say, because these are parallel lines just here, they are the interior angles. Yes, the co-interior angles. So what we've got here are 2 parallel lines, this one and this one. We've got a line across here. We've got, so these are parallel lines. We've got a line, we've got an angle in here, which is 2Y. We've got an angle here, which is 2Z. And then the co-interior angles sum to 180. If you know about corresponding angles, then this angle here and this angle here have to be the same. And therefore, you've got these 2 sum to 180. Let's put that expression. We've got 2Y plus 2Z equals 180. We can divide by 2, which means Y plus Z equals 90. So we're dividing everything by 2. So we've got a formula already. Then if you think about the large triangle, so the one that's going from here to here to here, if I put A, B, C, so that whole triangle there, this is going to be an X. We've called this one Z here. We've called this one Y here. Interior angles sum of a triangle sum to 180. So therefore another equation that I can use is X plus Y plus Z equals 180. Let's just write that here. X plus Y plus Z equals 180. Let's take this off as well. So we now have 2 equations here. You can see that this is y plus z. So I'm going to substitute in 90 where it says y plus z. So this becomes x plus 90 equals 180. That means x has to equal 90 degrees. And if x equals 90 degrees, that's the answer. And that's the answer is C.